Okay. Thanks very much, and welcome everybody. I actually think there's another session which has been, well, there was a workshop on analytics in the cloud, and I think one of the other sessions, which has just been finishing up, has been having some relevant, some discussions relevant to this panel. So it's a pleasure to welcome the other panelists. I see him here, Richard Harshman, here from Amazon Web Services. Oh, the others are sitting down. Okay. So, Rick. Okay, and Professor Tan Kien Lee from the National University of Singapore School of Computing. And last but not least, Jay Migliaccio, who's Director of Cloud Products and Services for Aspera. We have, I guess, 2 microphones here, and I think they're all on. So, although Rick promises to have a loud voice, but I think we'll all still use microphones. I'm a customer, very much a customer of cloud computing, and as we were putting this together, and as we were looking at the various topics that were being presented at this meeting and at other meetings, other sort of relevant meetings and forums, one of the things that struck me was we have this panel discussion is both posed as a question and also uses a lot of the very current terms. So we have in our question, is big data analytics ready for the cloud? And then we also have all 3 terms. We have big data, we have cloud computing, and we have analytics. So it's I would say this panel discussion is already in its title buzzword compliant. I guess my first, what I'd like to open up with is really an open question, because as a customer, I often see and think of big data analytics when we talk about big data. Well, we can talk about what big data means to each of us. But when I think of big data analytics, I think of conventional computing, high-performance computing technologies. And we hear a lot of discussion about big data analytics on those sorts of technologies. We certainly hear a lot about big data, large data, and data elasticity on the cloud. And we hear a lot about analytics on the cloud, although maybe, at least in my hearing, it's a lot of what I hear about is conventional analytics on the cloud, not necessarily big data analytics on the cloud. So we hear 2 of these buzzwords, at least I hear 2 of these buzzwords together often. And what I'd like to ask are, do we have sort of real case studies of real big data analytics being done on the cloud? And are there any impediments? Is this just a perception that big data analytics is not being done on the cloud and there's some impediment to moving onto the cloud? Or is it really moving as fast to the cloud, or can it move as fast to the cloud as other forms of big data analytics?
Great question. Maybe I'll take that one for starters. So analytics in the cloud requires, of course, the ability to move the data to the cloud, to store the data in the cloud, to run compute instances to analyze the data in the cloud, and of course applications. So all of that together is going to be required for doing big data analytics in the cloud. And my frank answer to you is absolutely. If you look in the ecosystem today, we've got technologies that can deliver data at high transfer speeds. We've got infrastructure capability through cloud platforms that provide a platform for innovation. And we have application providers that are doing the analytics. So I would say absolutely, we've got the ecosystem ready and available for big data analytics in the cloud.
Okay, so are there particular examples that people want to point to?
Yeah, so first off, it's a great question. Some specific examples that we see at Amazon Web Services of customers that are using our cloud platform in conjunction with fast file upload services like Aspera. Will be like UEFA for last year. Euro 2012 is a joint customer that we had together doing data analysis and processing on the AWS platform for that month-long tournament. I think a great example, and one that a lot of people are very excited about, is the NASA Mars rover Curiosity. That entire platform runs on Amazon Web Services. And what's interesting about that is people talk about, well, big data, and they talk about real-time analytics, and we had quite a lively discussion before we came here today about this. And the fact of the matter is, what people don't realize is that when you're millions of miles away from Earth to Mars, it actually takes 7 to 20 minutes on average to get data back to Earth or send data back to Mars. And the problem that NASA had with the previous Mars rover that they launched is that the amount of time it took to get the data back, it only gave them a few minutes, usually between 1 to 2 minutes, to make a decision on where they wanted the Mars rover to go next, so what coordinates they wanted to set. So the challenge in traditional infrastructure is they had to provision at peak, they didn't know how much data they would need, and they only had a few minutes to actually make that decision on where they wanted the Mars rover to go next. So with this latest Mars rover, the Curiosity that landed last year, they built the entire platform on AWS. And the fascinating thing about it is that because of the power that they could drive and generate, they generate over 12 teraflops of performance leveraging AWS, they're actually able to extend the amount of time that they can do analysis. So it used to go to 1 to 2 minutes. Now that they can extend that decision making out to 15 minutes. That is extremely important for people that are trying to analyze data. So they have the ability now to do those types of things. And then a few other, I think, examples that are good, that are more startup-based, are companies like Foursquare and Yelp that run completely on AWS, and there's a high amount of data that they need to process of people that are checking in, that are doing reviews, restaurant reviews, and things like that. So again, there's there's a ton of examples that we can give to you. We can talk about that offline.
So can I ask, well, maybe, Ken Lee, do you...
Sorry, I'm an academic, so whatever sort of use cases that I know about, actually I read about them. So probably AWS would be the better place to come up with all these use cases. Rather, instead, I would like to pose some questions instead. You know, from an end user point of view, there's a tendency to feel that the movement of data could be a challenge. You know, that it's very costly. It's time consuming. Probably because of the bandwidth or because, for whatever reason, right, to move large chunk of big data into the cloud, it takes a long time. Okay? To process it, and it takes, again, you probably will be doing batch processing using Hadoop, and that takes, again, some amount of time. So I'm actually quite happy to hear about the NASA project, which seems to give the assurance that the cloud can actually provide real-time analytics, truly real-time analytics. Right? I thought what will hinder people will be this transmitting data back to the cloud. And if I need them back again immediately, I need to transfer them back again. So that's one challenge that I see will probably hinder people from moving to the cloud. The other issues are probably the standard issues, right? Like security, privacy. So I'm not sure whether there are examples of companies that actually move their critical information to the cloud. Yeah.
I'll take the question on the data delivery. It's an area that we're focused on. The story that we have there is a company that has adopted a transfer technology in order to enable themselves to provide a cloud service around genetic sequencing. Genospace is an organization based out of Massachusetts. The founders came from the Dana-Farber Cancer Research Institute, and they concluded after their work there that they wanted to offer as a service genetic sequencing. In order to do that, of course, you have the challenge of receiving large amounts of data, analyzing large amounts of data, storing it, and then in the end delivering the results back to the customer. So there's another classic example of a company that is able to move the data, analyze the data, store the data, and deliver the results back to the customer.
So how much of that is real time? I mean, so, you know, and I guess I also had the same question for Rick in the Foursquare example. I can see the Mars example being very much real time. You have a limited, in that sense, it's time bound by definition because the Curiosity gets out of range, or so there it's time critical in a very obvious way. Maybe Foursquare, I have a hard time you check into Foursquare. It doesn't seem like there's that much analytics going on from the end user's perspective.
So with the Foursquare example, there's a couple of ways that you can look at it. There's a couple of ways you can look at it. With Foursquare, when you check in, it's extremely important for them as a business to be able to quickly identify who else may be in your sphere of influence or your network that is maybe close to where you just checked in or also in there, people with like-minded interests and things like that. They cannot do that if they don't have the ability to analyze that data in near real time, right? Now, the real time is going to be dependent on how they define real time. But to your question, cloud platforms, Amazon Web Services or other cloud platforms enable businesses to make those decisions. And I would say that I would change the answer to the question a little bit, is that I don't know necessarily if there are really technical limitations anymore that inhibit people from running data analysis or big data analysis on the cloud. I would say that some of the challenges that used to be there were going to be resource constraints, so infrastructure constraints. Because if you're running it in traditional infrastructure, you have to build for capacity. You have to build for peak. That's extremely difficult to do because you don't know how much capacity you're going to require. That could be eliminated with the cloud provider, AWS or potentially someone else. The other challenge that businesses talk to us about every day is their technical and data science limitations. So one of the fastest growing jobs that you see today are businesses looking for data scientists. So whether it's in academia, whether it's in businesses or enterprises, and know your background with Lilly, you're always looking for people that have the ability to be data scientists and developers. And that, quite frankly, is a limitation. And the third limitation that we see today from our customers when it comes to this question is, data is a competitive differentiator, but that's all it's not a differentiator if you don't know the right questions to ask about the data. And if you're asking the wrong questions in traditional environments, it can be extremely costly to fail, right? But in the cloud, when it's a pay model, you can actually experiment more quickly for less money. And if you're really pushing the innovation envelope, you can do more experimentation for a lot less money than you'd have to be able to do it in traditional infrastructure. Those are all things that can be addressed in the cloud.
So do you see the experimentation then as being a big driver of the use of analytics on large data problems in that setting?
For businesses that are, innovating and experimenting, whether it's in pharmaceutical, whether it's genomics, whether it's public sector, whether it's enterprises. So companies like Shell, it's the largest company in the world by revenue. They're continuously trying to do data analysis on where is the next big oil field. Now, whether that's out on an oil rig, out in the middle of the ocean, or somewhere deep underground, they're continually doing data analysis on that. And they need to do it as quickly as possible. Pharmaceutical, it's a race to get patents out. It's a race to get more research done so you can come out with a new product. They're doing that. If you can do that in the cloud, you can do it more quickly at more cost effectiveness. That pushes innovation. Now, before, your innovation is going to be limited by the amount of infrastructure that you've purchased. And we talked about this earlier. Well, the last thing I would say is, I met with a person the other day, and he told me that, I have KPIs. I have to come out with new services every year. The challenge that I have is, in my environment right now, it takes me 3 months to get a server. Once I get that server, I hold that server. I don't get it back. Within a cloud platform, you can get those instances in minutes. And then that gives you more time to focus on what differentiates your business. And in this example, it should be analyzing the data.
So a couple of things. So that addresses my question. Ken Lee, you asked about the critical and the real-time aspects of this. And now, Jay, the example that you gave for Genospace, I can certainly imagine that technology transfer, that transfer technology, data transfer technology being driven by the size of the data. But is it also driven, is there an analytic, I didn't hear an analytic driver to their adoption of that technology, or is it just the size of the data that they're working with, or is it actually also driven by the analytics?
In that case, the technology that they adopted from us was clearly related to the size of the data. Today, most people have a misperception about transfer capability with over wide area networks. The perception is that transfer speeds are sort of maxed out, and only software can only deliver files or data at certain transfer rates of speed, when in reality, in most cases, if you're delivering data over long distances, you're not actually using the full available capacity of your network. So we oftentimes are educating the market about how it's actually possible to deliver data anywhere in the world at the capacity of your network. And that was exactly the problem they were trying to solve.
I see.
So a couple of examples, if I may, just to address Ken Lee's question is, NASDAQ has actually come out with a completely new business unit called NASDAQ FinCloud that runs completely on Amazon Web Services. And the underpinning nature of it is real-time data and data analysis for organizations that are taking advantage of NASDAQ. One of the limitations, I think, previous to the cloud, what could have been bandwidth. So I don't think that we would disagree with that. But with companies like Aspera and with other underlying technologies that we provide, such as Direct Connect, where organizations can run a private line into AWS at either a 1 gig or a 10 gigabit per second connection and pay for that per hour, and you can transfer the data back and forth between your on-premise infrastructure and AWS, that's pretty powerful. And that can eliminate the concerns around, it will provide you with a quality of service, a guaranteed quality of service, because it's a fixed line, and it will eliminate the bottlenecks of bandwidth. And that's real-time, mission-critical data. Another good example is Netflix. So Netflix runs their entire platform on Amazon Web Services. They have 35 million subscribers worldwide, and they're doing real-time recommendation. Their recommendation engine is one of the most powerful recommendation engines today, and they're making recommendations based on not only your viewing history, but also what you may have searched previously. So let's say I watched a movie with Steve Carell. That will give me a recommendation the next time I search for other comedians that may be like Steve Carell. That entire recommendation engine needs to be in real time to give you the most appropriate search for what you as a user are looking at.
I see. So just as a note of process, rather than going through this whole discussion and then asking for questions at the end, since we'll be going through a variety of different topics, although I have to turn my head. Nonetheless, I'm going to continue to be on the lookout. So if people have questions that they want to raise while this discussion is going on, please indicate so, and we'll try to get to your questions during the week. Okay, here we go. All right, we have one. All right, she's got that. There you go, Jay.
Hi, I'm Andrew Yeo from Asia Pacific Broadcasting. I work with broadcasters, and broadcasters, as you know, are harnessing the cloud now, and not only just to transmit. Let's say if they get a movie from America to Singapore, if they do the traditional way, it takes a long time for them to receive it. But with modern technology like Aspera fast software, they could do it within a couple of hours or 1 hour less. But the other thing that broadcasters around the world, not only in Asia, is interested in is big data. They require big data to monitor what their viewers are watching and how many hours they are going onto the net to watch other things. Right? And when we say big data, they have to monitor millions of set-top boxes. Maybe can I have some comment from the panel how viable it is and how fast can they analyze
for broadcasters to do that kind of monitoring?
Yes.
Jay, do you want to start with speed?
Thank you. Thanks for the question.
So for sure, there's a lot of data being collected on all of the mobile devices today that people are looking at, and a need and an interest from the broadcaster and also from the advertising perspective to analyze that. From a data delivery perspective, we're there to ensure that the customers that need to move the files can do it as fast as they need to get the data over to the delivery systems or to the analysis systems. Can't say that we have customers that are doing the specific analysis you're referring to, but maybe you're aware of some?
So I guess in a general sense, it's important to think about the media workflow that you're talking about. So we work with organizations across Asia Pacific that are licensing content from other parts of the world. It could be Singapore or Malaysian broadcasters licensing media from Taiwan or Korea or the U.S. And the challenge that they have is not only getting the data, right? And traditionally it may be over tape being delivered to them or maybe over satellite. So that's one challenge. But the other thing is then transcoding that data. And transcoding that data is very difficult when these things come into play. So when the smartphones and the tablets and the various other devices come into play, and then you have to add on to that the different languages and subtitles and censorship and etc. And those are very unique in many cases to Asia Pacific. So the examples that we see, and we have many organizations that I can talk about generically in Asia Pacific that run their OTT, their over the top, on AWS and the entire platform. So everything from ingestion, so getting the data up into the cloud, and they would use a WAN acceleration technology like Aspera or other technologies, or they'll use Direct Connect with Aspera as well, like I mentioned. Then they'll use a transcoding service, so they can use a third-party transcoding service like Zencoder and run that on EC2, which is our compute instances, or we have our own transcoding service. So the point that I'm emphasizing is we can handle the end-to-end media workflow that you're talking about. The data analysis, the challenge before has always been that our customers tell us is they didn't have the compute capacity to process as quickly as they needed to be able to meet their needs. Because you can scale out with cloud infrastructure, you're able to do that more quickly. So what processes that used to take a few days, they can do now in hours, and they can do it cost effectively, because what's important to understand about cloud computing, especially from a billing perspective, is if you spin up one instance and run it for 1,000 hours, it's the same exact price as spinning up 1,000 instances and running it for 1 hour. So think about that. Okay? So that means that you can spin up 1,000 or 2,000 or 5,000 instances, do that job for an hour, and shut it off, and that's all you pay for. You cannot do that with traditional infrastructure. So that allows you to process the data more quickly and then analyze that data. Then you talk about storage. We have a storage service that has 2 trillion objects, 2 trillion unique objects stored on our simple storage service, and it regularly peaks at 1.1 million requests per second. So when people ask us about performance, well, we're handling on a global basis 1.1 million requests per second for this service alone. So we don't really see performance as a potential issue either. So the entire workflow that you were asking about is being done right now in the cloud, and whatever else people will need is possible.
Another data point I thought I'd share with you along that theme in the media space. A lot of infrastructure work is being moved over to service-based offerings, and in particular this transcoding capability that Rick alluded to earlier. One of the partners that runs on Amazon offers transcoding as a service now for organizations that want to do online video distribution and archiving. And when I was talking to them about their business, he explained that in order to do the transcode, of course, they spin up a virtual machine, does the transcoding job, and deposits the result back to the storage, the S3 storage. So I asked the question, well, how many times this has happened during your average month? And he said 20,000 times. So this example of 1,000 virtual machines actually is very real.
Wait. You're saying 20,000 times?
20,000 times a month.
That's separate spin up, spin down.
Yes. And each of those represent a transcoding job that they're doing on behalf of a customer that submitted a job.
It absolutely has to happen, because you just think about one organization like a company like Netflix. They have dozens of different formats that they need to transcode in, right? Because you've got different platforms. You've got the different operating systems with the smartphones. You've got the different tablets that you've got to transcode in. Then you've got the different languages. Then you've got the different bit rates. That's happening for every piece of content that they have, right? So you're talking about hundreds of different transcoding jobs, quite frankly, thousands that have to take place, and they have to do it as quickly as possible because they're paying money for this content. The longer it takes for them to digitize or get that content up into the platform, they could potentially lose money. So it becomes mission critical to them. So that gets to your question about, are people running mission critical things in the cloud? the simple answer is absolutely.
And yes, I was blown away by the number 2 when he said, I made him repeat, I said 20,000 times a month.
So, but there must be, is there...
it's elastic, right? The
right,
cloud
so
is about elasticity, and they're not doing this by clicking on some icons or buttons inside of a web page. They're doing this automatic through APIs, and that to me is the beauty of the cloud.
Yeah,
provision, scale down, shut down, and do the job.
That's very impressive.
Zencoder is the name of the company, if you want to look into it.
I will write that down. Okay. Okay. So if latency is not an issue in these processes, and you're doing Mars, you're getting the data from Mars, and the Mars Curiosity is being... So what's the limit of putting... Are we going to see air traffic control done on cloud services?
You know, I don't know. I think that we like to encourage people to think big. That's a trait of Amazon as an organization, and we think that we're trying to eliminate bottlenecks that organizations have had from a technological perspective. Really, if you think about the MIT Media Lab, which is run by a gentleman by the name of Joy Ito, one of his famous quotes is, if you're not innovating if you're not failing, you're not innovating fast enough. And kind of like the whole point of you're not pushing the envelope. And to push the envelope, you should not be beholden to infrastructure. You don't have to be anymore. You should be able to have the ability to spin up resources on an on-demand basis and then turn them off when you no longer need them and not pay for them. It's a democratization or a commoditization of resources that you don't need to have. To your question about air traffic control, potentially, it may be an eventuality. I don't know. What I do know is that there are, many examples of real-time data processing that are taking place right now.
So I think of real-time, things that are obviously critical real-time. So air traffic control, or Singapore, for example, has its whole ERP system, right, which is very much a real-time adjustment kind of thing.
So there's an organization here in Singapore that it's called Up Singapore. They're in conjunction, if you're familiar with conferences in the United States, called Up San Francisco. And Up Singapore, it's in conjunction with an organization called Newton Circus. They continually run. They go in and talk to different agencies here in Singapore to get data sets. And one hackathon that they ran last year was around this type of data. So they're creating, they're going to different organizations to get data from all the cell towers, all the ERP gantries, to be able to analyze traffic patterns and to be able to make help Singapore make determinations on how to continually improve the performance or the flow of traffic. The fascinating thing about this is during these hackathons, there's another one this weekend called Up Health. So it's about open data sets that are provided by the Ministry of Health. But this one that I'm talking about was open data sets, and you get a group of independent people together, and they're creating applications to be able to. So one that I thought was pretty cool was around, they'd go in and look at all the different parking lots across Singapore, because they got that data, and they're able to make a determination on what were the best ways to create an application that you could download on your phone to say, okay, I'm going to Plaza Singapore. Should I park at Plaza Singapore, or should I park at the Atrium, or should I park behind at Mount Sophia? Right? So it's actually trying to provide real-world data to people that are driving on kind of what the traffic patterns are like, and more importantly, where are the open parking spaces? Because the last thing you want to do is drive somewhere and then you don't have a parking space. So it's things like that, and these are things that are happening today in Singapore. The big thing that's been a barrier is opening up data sets. Data sets have to be open for people to be able to analyze them. If they're not, then you can't really do it.
So that comes back, I guess, to the experimentation. So I was at the earlier Up Singapore event. Unfortunately, I can't make the Up Health event because we have an open house at NUS that I have to participate in for incoming students. But the nice thing about that is as the agencies make this data available, then it's a great learning experience for everybody. And the people, I remember in the first one, almost all of it was done on the cloud.
Yes.
Absolutely.
So all the data is actually stored in the cloud. The process is then done in the cloud. They just did one for the National Environment Agency. And it's really important because, if you're paying attention, there's a lot of concerns around dengue. So the more that you can actually do the analysis to see where potential dengue hotspots, that could be preventative. So you want to be out on the offensive on these things. So you have to credit a lot of the agencies for opening this stuff out.
There's a question over here.
Yeah, hi. I'd like to ask a question around workload mobility. So obviously we're all talking about analytics.
Yeah.
Analytics is non-interactive in nature, and so therefore it's geographically independent of where the actual the data owner is. Now, it seems to me as though moving those workloads into geographical areas where there's excess capacity seems like a good idea. But in practice, though, is that actually realistic? Do you have scenarios where, for example, say East Asia might be using compute resources in the States because users in the States presumably are asleep at that time? And what are the challenges as well? Sorry.
Jay, do you want to address this? Because this is right.
Data moving is actually challenging, absolutely, with traditional software technologies. However, there are innovative solutions on the market that can move data at very high rates of speed now internationally, regardless of the distance. This is one of the hallmarks of innovative technologies like the protocol that the founders of Aspera developed, allowing, it's fairly horizontal, allowing you to move data at line rate, essentially at the speed of your infrastructure globally. So you can transfer a file from Singapore to Malaysia as fast as you can transfer a file from Singapore to London, given the same amount of bandwidth availability. So absolutely doable these days. We have examples of organizations in Asia-Pac that are running compute instances in North America for price reasons. It's just cheaper to do it there because it doesn't matter where we run the workloads. And vice versa, we have people that are looking at Asia-Pac regions for running workloads because they want to deliver a service in this region, but they happen to be based out of the UK, for example. So
I, as a user of the Amazon cloud, one of the first things I noticed the first time I used it was effectively, any user will see this. You can spin up the compute instance at any of the data centers, and you can put your storage at any of the available storage. But then, if you want them to interact together, the first thing you see, at least the first thing I saw, was they should be near each other, right? So, right, don't. So basically, they say you can put them in different places, but don't do that, right?
I suppose what I was asking was actually whether the CSPs. Thank you. I think I was asking more whether the CSPs are already looking into this. Are you finding that through your statistics that you're finding idle compute power in one part of the world and hot CPUs in others?
Does that ever come up?
So are you
in
asking
practice?
if we do that because to balance out utilization, or are you asking if the customers do that?
No. I'm asking if you do that. Yes.
Yeah. So that's a good question. I guess the short answer is no, we don't do that because that comes into our security mechanism, our security protocol. So what's extremely important to understand is, specific to Amazon Web Services, I can't talk to other cloud providers, but specific to Amazon Web Services, once where you decide to put your data, that's where it will remain. So, and that's extremely important for data privacy, data sovereignty, and things like that. So there's a reason why we have infrastructure we have 9 regions across the globe. From a European perspective, data cannot leave Europe. So when you spin up instances in Europe or you put content in our storage service in Europe, it stays in Europe. Same thing is in Singapore, same thing in Tokyo or Sydney. So we do not move data. Once the data is in Singapore, it stays in Singapore unless you as a customer want to move that data. Now that's to what Jay's saying. We do have customers that want to expand their services to maybe other parts of Asia or other parts of the world. So they may keep their data in Singapore and then may replicate that in other parts of the world because you can go global in minutes, and that's one of the benefits of a cloud platform. But we don't spread that out. One thing that I would say, though, which is innovative, and as far as I know, we're the only only cloud platform that does this. It's on the pricing model perspective. It gets to your question about utilization. If you have a non-time-bound workload, for example, so for data processing, it's a great example, we have a spot market. So that allows you to bid on unused capacity. So you can actually leverage our largest instance types, which, for example, a 48 terabyte of memory service instance, you can bid on that unused capacity if there is some. Let's say in the U.S. East, and let's say the normal price is $3 an hour. You can bid if it's available, let's say for 25 cents an hour, and if that meets the spot price, we will release that to you, and you can start doing your processing. So that's quite unique from a pricing perspective because you can actually then bid on the unused capacity.
A spot market for infrastructure computing resources.
Yeah, I wish I could have actually said that in my question because that's actually the answer that I was looking for. Thank you.
Okay. Next, they're going to come up with options and futures markets too, I would imagine.
Okay, so we started talking about the technologies and some of the issues in technology. So maybe let's just end about, and in our last few minutes, what about the market drivers for the large-scale movement of analytics onto the cloud? I mean, we have examples, right? So at least the examples are reassuring that it's actually happening and that there's not at least an insurmountable impediment for people's practical utilization of analytics with large data on the cloud. But I have some ideas in my own mind about what I expect to be drivers. But I'm curious for the panelists, what do you expect to be the drivers that really make this, that push towards what the subject of this panel is, big data analytics in the cloud?
I suppose a fairly generic answer is the value, right? At some point, the value of the resulting analysis has to be greater than the cost of obtaining that analysis. And given the commoditization of infrastructure and the scale and elasticity of infrastructure, whether it's a compute or storage or transport, that's driving out the cost of doing that analysis. So those are some of the drivers, obviously. On the other side, you could say maybe there's a cultural driver. We were talking earlier about Angelina Jolie having recognized that she has a genetic deficiency and it caused her to make some very difficult decisions. And that's awareness culturally of the value of this kinds of data and this kinds of information. So that's another example of a driver.
Yeah, I would think, things like cost effectiveness. If we can solve probably have some standardization. And what else? If we can deal with things like those data management policies, governance, that will probably help.
Yeah, I think one of the drivers is going to be, at a macro level, is going to be the continual drive of consumerization of data. So every single person, well, not every single person, but every person has a mobile phone. More and more people are getting things like smartphones and tablets. And we're creating a data trail, every single one of us, when we make a tweet, when we go on Facebook, when we check in somewhere. And that data is becoming a competitive differentiator for businesses. And what's interesting is it comes down to a question around privacy, not privacy about the cloud, but privacy on who actually owns that data, right? So when I take a photo on my phone, is it my data still, or is it the phone service, or is it my telco? That's going to be, I think, quite interesting to see on kind of a driver. Again, I don't think it has to do with cloud or data analysis, but privacy from that. And then, you have to continue to have a drive around security. Within Amazon Web Services, security is our number one priority. We wouldn't have the business that we do if security was not a key focus for us, along with operational excellence. But you have to keep that bar extremely high, not only for us, but for other providers as well, because this is still early days. At Amazon, we like to say this is still day one. So there's going to be a lot of innovation and a lot of iteration from a cloud perspective. So it's important for all service providers to keep an extremely high bar when it comes to these the different services that we offer.
So what you mentioned earlier, the quote from the current head of the MIT Media Lab about if you're not failing enough, then you're not innovating. I guess I see one of the drivers towards this is actually going to be failure. So in particular, Jay, you mentioned the example of that's been in the news of Angelina Jolie's health decision based on her own genetic information. Now, in the next few years, it'll be very reasonable. There will be millions of people getting their entire genomes done. Right? And effectively, I can't see any way to manage that other than using big data analytics in the cloud. Because otherwise, every hospital is going to need to have their own hydroelectric dam in order to power their data center. Right? So there's going to be, that's not feasible. So there's no other way that, at least in my imagination, there's a way to see a path forward where that amount of information is going to be accessible to consumers.
I think Richard mentioned earlier that one of the advantage of moving to the cloud is it allows you to try and to fail, right? And to figure out early that maybe your approach is wrong, or your business whatever questions is wrong or incorrect. So you will know that immediately rather than building your own infrastructure and so on and so forth.
I think to the point of healthcare, at least this is just my personal opinion, I really don't want my hospital to be building a data center. I'm hoping that they're focusing on coming up for cures of potential diseases and things like that. That's just my hope. But, we were talking earlier. I think what people have to understand, and there are a lot of misconceptions, but, you just think about a consumer storage service like Dropbox. Now, some people really like Dropbox. A lot of corporate organizations get scared about it. But the fact of the matter is there's no reason why you couldn't put your genomic sequence on Dropbox, have that completely encrypted and locked down, and when you walk into your doctor, you could show them your health records, as opposed to having to have your doctor have that on their facilities. Because quite frankly, you may change doctors, you may move. There could be changes. Maybe your doctor retires. But I think that because the cost of computing continues to reduce, because the ability to get to scale and to be able to have a lot of storage capability, individuals are going to be able to have a lot more power than they've had before. And then it will be interesting to see what companies do with that data.
Okay. Well, I think on that note, we'll have to end for time. So I want to thank the panelists and also thank the audience for your attention and also for the great questions. Thanks very much.
Thank you very much, panel. Thank you. Oh, we have one question, I think.
We do.
Is it okay?
If there's time, certainly it's okay. Yeah.
Okay. Thanks. I'll be quick. You've talked quite a bit about how cloud can reduce the barrier of entry to big data. Starting with elastic compute and now moving on to the services like transcoding, EMR services on top of Amazon. We mentioned hospitals. Every hospital isn't going to be able to have a Hadoop expert.
Yeah.
How do you see that market gap being solved with the shortage of data scientists? Is that going to progress where the innovation comes on top of these services to provide analytics more as a service?
I know what in fact, Jay mentioned one company that's doing just that, and there are a number of companies that are doing just that. I wonder if Jay or either any of our panelists can speak to that question.
So, great question, great point. I would say you're going to continue to see innovation in companies moving up the stack and coming out with services like that. We see it today, but you're going to continue to see that. The question about data scientists, it's going to be extremely difficult because everyone has asked for data scientists. I go into meetings, and one of the first things they ask me is, do you know any good data scientists? It's better than asking me why is a bookseller coming to talk about this. But literally every single business, it doesn't matter what you're in, is asking about data scientists. So how do you leapfrog that? I think, like you said, is on the innovation piece. People are going to continue to come out with services to address this.
I personally think we have to go further. So maybe some hospitals, maybe some teaching hospitals will want to have their own Hadoop expert, right? So I can certainly imagine the NUH teaching hospital will want to have their own Hadoop expert. But I don't imagine that a corner doctor running an individual family medicine shop is going to want to have their own Hadoop expert. And yet that corner doctor, he or she is also going to need to have access to an ability to analyze the genomic information that's coming from their patients. And so certainly there's there's room for analytic services to fill that gap.
Okay, well, thank you very much, gentlemen. And it's now time for a break. And before you